4.8, quadratic inequalities. So now we're going to graph quadratic equations with inequalities. So just like before, right? We know how to graph a quadratic function. And then the fact that it's an inequality means we're going to have a greater than less than sign, so it's going to be dot or slash. And then we have to shade accordingly. So the best way to shade, in this case, especially for quadratics, is honestly just do a test point. That's what all this is about. Best way to shade a quadratic is a test point. So let's do a couple examples. So we need to graph this. Now there's actually lots of ways to graph this. I'm gonna show you the two main ones, right? Let's find the vertex. Let's find the x-intercepts. So vertex, negative b over 2a. So in this case, I get negative 2 over 2 times 1, so I get negative 1. So my vertex is at negative 1. Plug that in, so I get negative 1 squared plus 2 times negative 1 plus 4. Notice that the negative is inside the square, so this becomes 1. Negative 2 plus 4, and I get 3. So my vertex is at 2, 3. So if I'm going to graph this, I'm going to get negative 1 and 3. It's a positive x squared, so it opens up like that. Now I got to shade less than. So again, if you're in proper notation, less than just means below. So we'll shade all below that. But a lot of times with this, you generally want to try a test point because you're not always doing proper notation. So let's do a test point first. Pick a point like 0, 0. Plug into the equation to see if it works. 0 is less than 0 squared plus 2 times 0 plus 4. So 0 is less than 4. That is true, so we do shade in that spot. So, right, so just like before, we graph it, find the vertex, graph it, and then if it's in proper notation, you can go less than, below, greater than, above. If not, you can always do a test point. Either way works. Let's do another one here. Now let's talk about this one. If I was going to do this one, the vertex would be disgusting. I'd get negative 3 over negative 4. I get 3/4. Oof, I don't want to deal with 3/4. So we get this, do a little work. We have to find the y value, so you plug it in. Square it, so that's going to be 9 over 16 times negative 2. This reduces, I get negative 9 over 8 plus 9 over 4 plus 5. Let's get a common denominator for everything. So 2 times 2, 8 and 8. It's a little review of how to add fractions. No biggie. And I'm going to get 49 over 8. So that's my vertex. 0.75 and 49 over 8, which is about a little more than 4. 48, 6 and 1/8. 6.2, 1.25. Ugh, something ugly like that. Anyway, let's graph that. So it's at 1.15 and 6. So it's something like this. Notice it's a negative, so it's opening down, and it's dotted. Proper notation, less than means below. So below that, the vertex, so right here. So we get that. Next one, let's do the last one of these and then move on. Right, so let's find the vertex. Easiest way to graph. Negative b over 2a. That's what x equals. So in this case, that is a, b, c. I get x equals negative 4 over 2 times negative 1. Negative 4 over negative 2, or just 2. So my vertex is 2 and something. Plug it in. Remember, this goes first, so that's 4, and then you times by a negative, because the negative is on the outside. So negative 4 plus 8 plus 1, which gets me 5. My vertex is 2 and 5. Y-intercept is 1. Easy. Plug in x is 0, so y-intercept is 1. It's a negative, so it's opening down. It's solid, so it looks like this. Right, like that. Now again, greater than, so shade above, but this will show you again. Let's do test points to practice, right? Let's do a point like 0, 0. If I plug in 0, 0, look what happens. 0 is greater than 0 plus 0 plus 1. 0 is greater than 1. That is false, right? So I don't shade this part, I would shade the opposite part. So that's how the test point works, right? Also greater than is above. But again, that only works when it's in proper notation. Test points always work. So there's that. Now the second part, they might want you to solve a quadratic equation using graphing. Well, the way that works is this. Look at this picture here. If I want my equation to be less than 0, well, where's the graph less than 0 at? Well, from here to here. So your answer is between those 2 points, x1 and x2. And now on this one, where's your graph less than 0 at? So right here's the graph. Here's where it's less than 0. So it's these 2 spots, here and here. Likewise, if you want your graph to be greater than 0, you want it to be positive. Look at this graph here. Where is it above the x-axis, which is right here? Well, it's here and here. So it's this spot and this spot. And then this graph, right here's my x-axis. Where is it above? Well, in here it's above, right? So it's this spot. So let's do an example just to show you what I mean. But next, just to start, let's take a step back and let's do a picture of it. Let's say I gave you x squared minus 5x minus 6. And I say the answer to this is 2 and 3. It looks like this. I want to know where this graph is greater than 0. Well, look at the picture, right? They want greater than 0. They want positive. So where's your graph positive? Well, it's positive right here and right here. So your answer is actually this part, which is 3 on, 3 to infinity, or x is greater than 3. And from here on, so here's 2, where x is less than 2. Those are my answers. X is greater than 3, x is less than 2. Let's do a couple more. Let's skip down for now. Let's do this one actually. So this one you're like, okay, how do I do it here if I don't have a picture? Well, we gotta factor it. So I could factor this. This is x plus 5, x plus 3. So less than 0. Split it. X equals negative 5 and negative 3. So how are we going to do this? We're going to graph it. You go to negative 3. Go to negative 5. Notice it's positive, so it opens up. Now the question is, where is it less than 0? So look at your graph. Where's your graph below the x-intercept? Right here, right? So that's between these 2 marks. So you're going to say x is between negative 5 and negative 3. Between those 2 things. That's where your less than 0, between those 2 values. Alright, let's do a couple more. Right, so if I was looking to do this one, and these I'll just do a picture. Get the idea across. Right, so let's say, just to get the idea across. Let's say this is negative 3, this is 4. I want to know where this thing is greater than 0. Right, if you look at your graph, you're like, wait, it's right here is bigger than this, so it's this part. And right here it's greater than 0, so it's this part. So you would say x is less than negative 3, and x is greater than 4. Right, both those parts. That's kind of the idea of this one. You just want to graph it. If you have a graph, where is it greater than 0, where is it less than 0 at? Okay, let's go to one last thing. An application problem. Putting everything we know from this chapter all together. A midfielder kicks a ball towards the goal during a match. The height of the ball in feet above ground is h, and t is time represented by h of t. So again, h equals height, so how high is it? And t is time, since the kick. And then we have that equation. Find the time at which the ball reaches max height. So remember, if anytime I want you to find the max height, that is just the vertex. So you got to find the vertex, h and k. In this case, remember, h is how long. This is like time. When does it reach max height? and k is the actual max height. So find the times. We're looking for the x value. So all we gotta do here is find the vertex. X equals negative b over 2a. So this is negative 2.4 over 2 times negative 0.1. It's an application problem, so feel free to use a calculator. I'm going to use one right now. So I got to get out of this. Second quit. Negative 2.4 divided by 2 times, we have parentheses, 2 times negative 0.1. I gotta make sure it's in parentheses down there. And I get 12. Hey, not bad, 12 seconds. So it took 12 seconds to reach its max height. Now it wants to know what's the max height of the ball. Well, remember, what we just found was the x in the vertex. This is 12 seconds. If you want to find the y in the vertex, which is the max height, you just plug it into the equation. So we're going to find h of 12 seconds. So negative 0.1 t squared, negative 0.1 times 12 squared plus 2.4 times 12 plus 1.5. Again, we just use our calculator and type it all in. So negative 1 times 12 squared plus 2.4 times 12 plus 1.5. Max height is negative 113.7, and that can be, so that's wrong. Where did I make a mistake? Oh, it's negative 0.1. I put negative 1. That's my mistake. I was like, that can't, my height can't be a negative number. It's all the way in the ground. So here's a trick. Let's go all the way to the front, because I don't want to retype all this. All I want to do is add a decimal. So you go right here. Let's say right there, I guess. And press second insert. See the little INS? That's an insert. So let's insert a number anywhere you want. So add a little decimal there. So I don't have to retype everything, just add the little decimal. Hit enter. 15.9. That makes a lot more sense. So the height is 15.9. That's the max height reach. This is in feet. So max height is 15.9 feet. What is the height of the ball when the midfielder kicks the ball? So anytime I ask you a question like this, when he kicks it, that's the initial height. That's what this is asking. What's the initial height? And all you do there is plug in time equals 0. So we plug in time equals 0 into our equation. H of 0. So negative 1 times 0 squared plus 2.4 times 0 plus 1.5. So 1.5 feet. It's initially at 1.5 feet. So if I ever want to know when does this happen at the start, that's initial. So it's typed in 0. And then D, at what time will the ball hit the ground? So I want to know when the height is 0, right? Not time, the height is 0. So I'm going to set my equation equal to 0. Now lots of ways to solve this. I can use a quadratic formula. I can use complete the square, which would be ugly. Probably the best way to do this is honestly just graph it. Just use your calculator. It's all ugly in decimals. So we go y equals. We got to type that equation in instead. So let's go negative 0.1 x squared. Remember, we don't have a t, we use an x. Plus 2.4 x plus 1.5. So we're going to try to solve this, try to find the x-intercepts. And I have 1, that's a negative value though, so I don't even care about that one. I don't want a negative height. And I can't see the other one. So remember, we have two choices. You could do zoom out, or you could do zoom fit. I'm going to try zoom out again. Hopefully it doesn't fail me this time. So I'm going to go a little bit more over here, because I think it's more on that side. Hit zoom out, hit enter. And then there we go. So that's a nice picture, right? Again, that's going to be a negative answer. I don't want that one. I want this answer. Remember, the way we find that point where it crosses, we go second calculator, and we find the 0. And all we do is you want to go closer to where 0 is. So move your graph till it gets kind of close to it. Then we're going to go left bounce, we're going to go a little left. And then right bounce, we're going to go a little past the x-intercept, so there. And it wants to search in between those two values. So hit guess, hit yes. And you get about 24. So that right there, by the way, see this, how the y value is negative 1 e to the negative 10? That's just a calculator way of saying a really small number. It's 0, essentially. So my answer here is 24.6. It takes 24.6 seconds to get back to the ground. if the height of the goal is 8 feet, at what time during the kick will the ball be able to enter the goal? So in this case, my height's going to be 8 feet. Right, so how long does it take to get to 8 feet? So it's actually a very similar equation. Now I have two things here. What I'm going to do is I already have this one graphed. I'm going to graph this one also. I could set equal to 0 and do it again, but the easiest way to do is just graph that one also. So I'm going to go to y equals. Let's make this an 8. I want to see where these two graphs hit each other. So where is it less than 8? So I got to find where they intersect. So second, calculate. Let's find the intersection. Actually, let me draw it so you know what we're talking about, right? So we have this as our kick. We have this. This is 8 feet. I want to know when I can actually make a goal. Well, I probably can make a goal from anywhere from here to here. And from here to here. Only times it's between 8 feet, right? Because if it's over 8 feet, I can't, I'm over the goal. It's only between these two times. Could I do it? So that's what that's what I'm trying to find. So let's find the first intersection. All we do is get close to it, hit enter for the curve, and then it jumps to the other one, you hit enter. So that is about 3.11. So right there it's 3.11. So between 0 seconds and 3.11, I can make the goal right here. Now I gotta find this one right here. So let's figure out where that's at. So we're gonna go back, second calculate, intersection, go all the way to the other one, hit enter, and I get 20.88 seconds, 20.9 seconds. Now remember, I know where it hits the ground already. We did it earlier. It hits the ground at 24.6. So I can only make the goal between those 2 seconds, 24.9 and 24.6. Only time my soccer ball can actually make the goal is before we get to 8 feet and after we come back from 8 feet. 8 feet. That's the lesson.